So we're going to look at risk and return. So by the end of this lesson, we must be able to understand the relationship between risk and return, defining what risk is and how risk can be measured. We'll also discuss the different types of investors and their attitude towards risk to ascertaining what type of investor will undertake a certain portfolio. We'd also want to understand and explain risk and return in the context of portfolio management, and also how to calculate risk in terms of the coefficient of variations, the standard deviations. Then the other part of the course objectives will be dealt with later. To start with, in your own definition, what do you think risk is? Let's start from what we know. In your own definition, what do you think risk is? What is risk? So in the context of investment, risk simply refers to uncertainty or the variability of actual returns compared to what you expect. Now, risk usually encompasses the possibility of losing some or all of the investments that we put in terms of capital due to factors such as market fluctuations, business conditions, and then foreseen events that may occur in an investment. A return simply represents what? A gain or a loss on an investment. So this is typically expressed in terms of percentage of the initial investment that we had. So it takes into account both what we call capital gains, which are the increases that we have in value of investment. It also considers income in terms of dividends or interest. Then we also have what we call expected return, which is simply the average of the expected return from an investment. It is simply a weight that's calculated against the possibility of an occurrence. So we're going to calculate the expected return, the standard deviation, the coefficient of variation, the variances in that order. So I have already explained what a return is and what risk is. And I'm going to actualize them using this example. So now you need to follow me closely. So how do we calculate the standard deviation? How do we calculate the expected return? So we're looking at a stock called BW. So this stock has returns as follows: negative 15%, negative 3%, negative 9%, negative 21%, negative 0.33. This is the return in terms of percentages. And the probabilities that we have in terms of usurping these particular returns is 10%, 20%, 40, 20. So these ones are the probabilities. So we want to calculate the expected return is simply multiplying the return times the probability. So 0.15 negative times 0.10, we get 0.015 negative. We multiply this by that, we get this answer. Multiply this by that, we get this answer. Multiply this by that, we get this answer. Now, the sum total of the returns times the probability is what we call our expected return. And so in this case, 0.09 is equivalent to 9%. So our expected return is 9%. Are we together so far? Is there anyone confused at this point? Okay. So now we go into calculating, we want to calculate the standard deviation. So in determining standard deviation, whenever we're calculating standard deviation of any calculation, whether it's in statistics or in this course, we usually square root the variance. So in this case, we're going to calculate standard deviation, but by definition, the standard deviation is simply a statistical measure of variability. how much we're deviating from our expected return. That is called the standard deviation. It's simply the square root of the variance. So it is also in our statistics under discrete distribution. So now let's look at it carefully, how we're going to calculate the standard deviation. So we have stock BW, we multiply the return times the probability, we get the values here. Return times probability, we get the values here. The total we got was what? Our expected return. After getting the expected return, from each of these returns, we're going to subtract the 0.09. Then we square the answer and multiply it by the probability. So negative 15% minus 9%, we square it. Then we multiply it by the 0.10. This is how the answer was calculated. Then how do we get this answer here? We subtract negative 0.3 minus 0.09. We square the answer. We multiply by the probability of 0.20. So we get 0.0288. We also calculate our return 0.09, or 9% minus 9% is 0. You square the 0 is 0 times the probability, we get 0.40. So this is what we are doing in this column. So we do the same for each of the individual returns and you sum them up. So this is how we get the 0.1728. Are there any questions so far? So the total that we are getting here is not the variance, but is in fact our, it's not the standard deviation, it's a variance. So this is how we get the variance. So far, so good. Okay. Now, after getting the 0.1728, we now square root it. So 0.01728, when we square root it, we get our 0.1315 or 13.15 as our standard deviation. So that is how we find the standard deviation in that context. So now, if we're given another asset, we will need to compare it in terms of coefficient of variation. So how do you find the coefficient of variation? Coefficient of variation is simply the ratio of the standard deviation to the expected value, which is a mean. So standard deviation divided by the expected return. So our standard deviation, we've just calculated it as 0.1315, which is this figure here. Then the expected return, which was 9% or 0.09. When you divide these two, we get what we call our coefficient of variation. That is how 1.46 is calculated. Okay, so quick, can you remember? You're given two assets, asset A and asset B. The test of nature, we can have a normal, we can have a what? Boom, we can have a what? A recession. So we have asset A, the returns, maybe here we have 100 kwacha, and here we have a boom, maybe 500, and also a recession, we're not doing too well, there's a 200 kwacha. For asset B, the returns for asset B, we may have maybe here a 200, and here a 400, and in the recession, we're not doing fine, we're getting a negative 100. In the probabilities, maybe we're given probabilities as maybe 0.5, chance of getting a normal, 0.3, chances of getting a boom, and 0.2, chances of getting our recession. And the total must be equivalent to a 1. Now, what did we say to find the return for asset A? Return for asset A, we multiply the return times the probability. So 100 times 0.5, we get a 50. 500 times 0.3, what do we get? A 150. Negative 200 times 0.2, what do we get? Negative 40. In total up here, the return for, expected return for asset A, what do we get? get a 160. That's how we calculate the expected return for asset A. Who wants to try? How do you find the expected return for asset B? What do you do? Yes, Bianca. How do we get the expected return for asset B?
Okay, so for asset B, I think we do the same as we did for asset A, where we multiply the 200 by the 0.5, which is the probability.
Excellent. The probability 200 times the probability 0.5. Here, what do we get? 100. 400 times the probability here, what do we get? 120. The 100 times 0.2, what do we get? Negative 20. Then the expected return for asset B, what do we get? We get a 200. So this is how we get the expected return for asset B. Are we following? Okay.
Yes.
So now how do we get the variance for asset A? So remember, the return for asset A, we subtract the expected return for asset A, we square the answer and multiply by the probability. Similarly, for asset B, the return for asset B, we subtract the expected return for asset B, we square it, and you multiply by the respective probability. So asset A, we're going to go here, 100 minus 160. What do we get? 100 minus 160, we get negative 60. You square the answer, we get that 600. Then we multiply it by the probability of 0.5. So that will give us 1800. So that is how we are finding this column. So here, 1800. Can somebody lead us? How do we find the answer here? What do we do? 500 minus what? Minus expected return, which is 160, equals, then we square the answer, then you multiply by the respective probability of 0. What? 0.3. So here we're going to get 34,680. Right, then here, 200 negative, you subtract what? 160, you're going to get negative 360. Please be careful here, they are negative, negative. Then the answer, when you square it, we're going to get a positive 129,600. Then you multiply it by the probability of 0.2. You're going to get what? 25,920. So when we add all these, 25,920 plus 34,680 plus 1,800, we're going to get what? 62,400. What is this 62,400 code? The 62,400 is called what? The variance. When you square root it, it is called the standard deviation. 249.80. And we divide this standard deviation by our expected return. It's called the coefficient of variation, CV. So we divide this by 160. We're going to get 1.56. So coefficient of variation is very important because the higher the coefficient, the more risk. So we want to know which one has more risk between the two assets, A or B. All right. So who can lead us now to the column for B? How do we find the variance, standard deviation, and coefficient of variation for asset B? Yes, anyone? Charles?
Good afternoon.
Good afternoon.
Okay, so I guess we're going to say 200, which is a return for asset B, minus 200.
So expected return for asset B.
That square D times 0.5.
Yes, correct. So choose to give us 0, okay? 200 minus 200 is 0. Whether it's square, it is 0. Times 0.5 is 0, correct. Yes, the next here, what do we do? 400 minus what? Continue.
Yeah, so it's 400 minus 200.
Which is 200, yes.
Times 0.3.
Then you square it first. Then times.
Square it. Oh, yeah, square it then times 0.3.
Excellent. So we get what? 4,000. All right. Then lastly, negative 100.
Negative 100 minus 200 squared times 0.2.
So here you need to be careful. Negative 100 minus 200, we're going to get minus 300. So minus 300 squared, you're going to get 90,000. 90,000 is a positive. Whenever we're squaring anything, it becomes positive. You multiply it by the probability of what? 0.2, which will give us 18,000. So the total we're going to get is called what? The total we're going to get is called what? Our variance.
That should be a variance.
Correct. And when you square root it, what is it called?
Standard deviation.
Excellent. Which is 173.20. And when you divide it by the expected value of 200, what do we call it?
That's it, coefficient of is it variation or something?
Yes, coefficient of variation, which is 0.866. So which one has more risk between asset A and asset B in terms of risk? We say the higher the CV, the more risky the return. So which one has more risk?
Asset A. Return, or rather return A.
So asset A is risk.
Asset O rather, yeah.
Is riskier. So now, typical questions that come in this nature will ask you, calculate the expected return for each portfolio, correct? Calculate our variance standard deviations, we've done all this. Which one has more risk? So the higher the CV, the more risky. So in portfolio management, we are really calculating the deviation from the expected return. So this one is deviating more, it's more volatile. So if you're a risk averse investor, you're going to most likely avoid this and go to the other one. So we have three types of investors. We have what we call the risk averse, we have the risk seeker, and the risk neutral. So in terms of risk, the averse one will avoid risk as much as possible. The neutral will be indifferent. Anything that is, as long as they don't lose out any money. Then there's what is risk seeker. The risk seeker will always follow risk. The assumption is that the higher the risk, the more the return. Men are more risk seeking than women generally. All right. So suppose we are told that this guy decided to invest weights as follows. In asset A, he invested 60% of his money. In asset B, he invested 40% of his money. So they ask you to calculate two things. What is called the portfolio expected return. So expected return for the portfolio is simply the weight for asset A and the expected return for asset A plus the weight for asset B and the expected return for what? Asset B. So in this case, what was the weight for asset A? 0.6. And what was expected return for asset A? 160. Then we go to the weight for asset B, 40%, which is 0.4. And what was expected return for asset B, which is 200. So what we're calling a portfolio is a basket of what? Of investments. So in this case, we are calculating the entire portfolio. So When we calculate that, we're going to get the average for the entire portfolio, which is 176. That is how we get it. Is that clear? Are we moving together?
Yes.
Then there's also what is called the portfolio variance. Portfolio variance is simply given by the weight for asset A, we square it, times the variance for asset A, we square it, plus the weight for asset B, we square it, times the variance for asset B, we square it. All right? Plus 2 weight for asset A, weight for asset B, and the covariance for asset A and B. Now, how do we calculate the covariance for asset A and asset B? We get the probabilities that we had. We had 0.5, we had 0.3, and we had 0.2. Then the return for A minus the expected return for A, and the return for B minus expected return for B. We multiply these 3 columns. We get the probability of the probability times the expected return for A, probability for A, sorry, minus expected return for A, times the return for B as expected return for B. In short, what I'm just simply saying, if this is column A, this is column B, this is column C, we just multiply A times B times column C. So here, if we go back to our initial table, the return for A was what? 100. 100 minus 160, it is negative 60. So here we have negative 60. Then 500 minus 160, and also minus 200 minus 160, just these columns. So here we have 100, 500, negative 200. 100, 500, negative 200. The return was 160, 160, 160. So we just getting the differences here. That's what all we're interested in. So in this case here, we had negative 60. Here we had 500 minus what? 160 is 340. Then here minus 200 minus to be negative 360. Okay. We do the same. Here the values were what? 200, 400, negative 100, and the expected return was 200. So 200, 400, negative 100. 200, 400, negative what? 100. So we are subtracting the expected return, which we have, which is 200 throughout. So here, what are we getting? You're getting 0. You're getting what? 200. You're getting negative what? Negative 300. Okay. Then you just multiply these 3. 1, 2, 3. 1, 2, 3. We total up. So the first one, 0.5 times negative 60 times 0. We're getting a 0. 0.3, 340, 200. What are we getting? Times 340 times 200. We get 2040. And here 0.2 times negative what? 360 times negative what? 300. The total answer we get is what? 21,600. So collectively, this is what we call the covariance. So here you're going to get 23,640. Covariance of what? A and B. So covariance A, B. Now this is when we can go to this our grand formula here. So our portfolio variance. So the weight for A, remember, was 60%. We went to asset A. The variance for A was what? We created the variance for A here as 62,400. So don't square it again. If you want, you can get this and square it back, but I usually prefer just get this one since it's a variance already. 62,400. So we put what? 62,400. Are you following? Then we go to the weight for B was 40%. So the 40% we square it. Then the variance for asset B is 30,000. So we put our 30,000 here. Then plus 2, weight for asset A, 60%. Weight for asset B is 40%. Then the covariance is what we just calculated, which is 23, right? 640. All right. Then you just evaluate this entire block. So 0.6 squared times what? 62,400 plus 0.4 squared times what? 30,123 plus 2 times 0.6 times 0.4 times 23,640. So the entire value you're going to get is 38,611.2. This is the portfolio variance. Portfolio is when you combine both assets. So the variance you're going to get from the portfolio is 38,611. They'll also ask you for the portfolio standard deviation. We're just square rooting the portfolio variance. So our answer when you square root this, we're going to get 196.497. So this is how we get our portfolio standard deviation. So it's like a procedure. It looks easy when somebody's solving, but there's a lot of work we've done already. Are we following? Any questions at this point? Ask now or forever hold your peace.
Yeah, following. We are following personally.
Okay.
I guess it needs a lot of practice also, just to be
Yes.
able to master the whole procedure.
Exactly. Yeah, it needs practice. But I'll share the video so that you could find time to because I'm going to give you homework. I'm going to give you homework on this. So I just want to just clarify one thing. There's an instance when you are not given what? When you're not given the probability, sometimes you just come asset A, asset B. So in an event where you're not given probabilities, we assume they are equal. So if there are three states of nature, we're assuming that is 1/3, 1/3, 1/3. If there are 4, 1/4, 1/4, 1/4. If there are 2, 50%, 1/2, 1/2. All right. So what I'm saying is that examiners sometimes want to test your ability to understanding our ability to understand. So there's a question there to say coefficient of variation. What is the formula? Coefficient of variation is simply standard deviation divided by expected return. Don't swap them. It's always like that. Are you together? Don't swap them. It's always like that. Any questions so far? Any other questions? Are we following? So this is very important. So the higher the CV, the higher the what? The risk. The lower the CV, the lower the risk. So, any other questions before we end? So there's also what is called the coefficient of correlation. Correlation coefficient you can also calculate that it is a value that ranges between -1 and +1. So coefficient of correlation is very important because it measures our direction of the investment. So to find the coefficient of correlation, we just divide the covariance of A and B divided by the standard deviation of A times the standard deviation of B. So if we get a negative answer, we say these are negatively related. If we get a positive answer, we say these are positively related. So you need to also understand correlation is very important because it's the statistical measure that will give you an objective of how the two securities are moving. Sometimes you have securities that are moving positively, sometimes you have securities that are moving in the negative. So when you combine them, they'll just give you a single straight line. This is what we call diversification. It's very important for investment management for us to ensure we understand the degree at which these variables are related. So it is very important to understand this concept of correlation in investment because investors would be keen to want you to know how the magnitude and the existence of the variables are interrelated. So when you be doing your research as well, it's very important that you better give advice on an investor based on the type of the direction of risk that each of them may have. So basically, this is what I had for you. I'll send the homework in the respective groups. In the notes there. Thank you so much and have a great day.